So in this question, you're given that fx is 1 by mod x if mod x is greater than or equal to 1, ax square plus b if mod x is less than 1. Find a and b if f of x is continuous and differentiable for all x belongs to R. So mod x less than 1 means x belongs to minus 1 to plus 1, right? And mod x is greater than or equal to 1 means x is either greater than or equal to 1 or x is less than or equal to minus 1. So the function f of x is 1 by mod x in this interval, ax square plus b in this interval. So as you can see, ax square plus b is a polynomial function. This is always continuous and differentiable in minus 1 to plus 1. So within this interval there is no problem of continuity and differentiability. And 1 by mod x is also continuous and differentiable in x greater than or equal to 1 and x less than or equal to minus 1. Because the problems of continuity and differentiability of 1 by mod x occur only at x is equal to 0. Because when x is equal to 0, this is a rational function where denominator is becoming 0. And mod x also have differentiability problems at x is equal to 0. But this function is not defined anywhere in the neighborhood of x is equal to 0. So within minus 1 to plus 1, the definition is ax square plus b. And outside this, the definition is 1 by mod x. So 1 by mod x is not defined in the neighborhood of 0, hence there are no problems of continuity and differentiability within this interval. So if at all there are some problems, they have to occur at minus 1 and plus 1. So let us try to ensure continuity and differentiability at these 2 points. So first, continuity at x is equal to 1. So limit x tends to 1 plus f of x, limit x tends to 1 minus f of x, and f of 1 have to be same, right? So as x tends to 1 plus, as x tends to the positive neighborhood of 1, the limit value comes by substituting 1 in 1 by mod x. It is 1 by mod 1, which is equal to 1. And on the left neighborhood, the value of limit can be found out by substituting x equal to 1 in ax square plus b. It is a into 1 square plus b, which is equal to a plus b. And the functional value is also equal to 1. So the same thing happens at x is equal to minus 1. So for continuity, 1 has to be equal to a plus b. This is the first condition. For continuity, a plus b has to be equal to 1. Next, for differentiability. So let us do the right differentiation of this and the left differentiation of this. Let us equate both of them. So what is the right differentiation? That is f dash at 1 plus is nothing but, so 1 by mod x. So 1 by something's differentiation is minus 1 by something square into the differentiation of mod x is mod x by x. The differentiation of mod x is mod x by x. So that is equal to, so if you put 1 here, so minus 1 by 1 into 1, so you get minus 1 as the answer. So the differentiation on the positive neighborhood of 1 is minus 1. Next, what is the left differentiation? F dash at 1 minus is nothing but 2ax at 1 minus, which is equal to 2a. So the differentiation, the right differentiation is minus 1, the left differentiation is 2a. Hence, for this to be differentiable at x is equal to 1, 2a has to be equal to minus 1. This implies a is equal to minus 1 by 2. And once a is equal to minus 1 by 2, b has to be equal to 1 minus a. It is 1 plus 1 by 2, which is equal to 3 by 2. So these are the values of a and b for which the function is continuous and differentiable for all x belongs to R. So if you do the same derivations at x is equal to minus 1 also, you see that you get exactly the same equations. So a equal to minus half, b equal to 3 by 2 ensures the continuity and differentiability of this function.